work to do.
Greetings from Terry D-Lab. Today on the bench I have a Sunn 2000S 100 watt head in need of repair. It came in here with blown rectifier tubes and one shorted output tube. Let me show you the extent of damage and we'll get her fixed up. So the story is, the original owner bought himself a set of new 6550 output tubes. He replaced them, turned the amp on, everything was fine for a few minutes. Then he saw some flashes out of his rectifier tubes and she shut down. Now unfortunately the flash he saw damaged these nice old GE GZ34s. So now, if you can hear it, they kind of have rattles like something a baby would play with. So unfortunately these guys are history. The extent of damage went beyond the GZ34 tubes. If you look right here, there's a little ohmite brown devil type. It's got the hole through the center. There's a pair of them here on this rectifier, and there's a pair of them over here on this rectifier. They're 47 ohm at 5 watt. This one, if you can see it, is cracked, and I measured him, he's open, and so is this one. So we're going to have to swap those out, and then I'm going to bring this thing up on a variac carefully and make sure the high voltage comes back. The other thing that I spotted right off the bat is we've got some old bias caps in here. They got to come out. I changed those immediately. There's another one, and there's a big old filter cap right here. He's a 600 volt 20 microfarad guy, and there's a bulge right there, so he's coming out too. So there's the extent of the damage. I'm going to go through and replace those components. I've got the caps and resistors here, and I have a new set of GZ34s. Then we're going to pull the output tubes and bring this thing up and hope it comes to life. So I just found something that I needed to point out. Now here is that big 600 volt cap I replaced, and if you remember, it was on a clamp. Well, I installed a terminal board here to put it on, and I soldered this ground direct to the chassis, so we got a really good connection. Now I'm over here changing out this bias cap, which was also in one of those clips, and here's what I noticed. See this terminal board? Watch it. Boing, 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 boing. Guess what? That's a ground point right there. That's like really bad news. This was probably causing some intermittent issues with the amp. Unfortunately, this rivet is underneath the metal plate that holds a power transformer, so it'd be a job to get to it. So what I'm going to do is take an X-Acto and get the corrosion off here, and I'm going to scrape this chassis, and we're going to lay a bead of solder with my gigantic Unger iron and fix this ground. So here we go. I got all the wiring out of the way so we don't cook anything. Here's a big 1000-degree Unger. Gonna lay him right down there and flow some solder from that terminal board ground to the chassis. That should take care of the problem. So there it is. The ground's intact. Terminal board doesn't move. Let's change out this cap. So we're done here in this area. New cap's installed. Put a little adhesive here to hold it into the bracket. The ground's fixed. All's well there. There's our other bias cap. Same thing. Glued into place. Of course we got the big 600 volt cap here. The resistors are installed, and I buzzed out the others. That all looks good. Then I came over here into the power supply area that feeds the preamp tube, and here's another terminal board. If you look down here, you can see some solder. Somebody else discovered the loose terminal board and tried to fix it, but guess what? It didn't fix it. Their solder connection is loose from the chassis. They either didn't clean it or they couldn't get enough heat on it, so I'm going to fix that. To gain access to to this point here and get it cleaned and all that, there's a couple wires here that were hooked to the terminal board, so I had to desolder them, swing them out of the way. But now I got a clear shot to get the younger in there and get that baby soldered correctly. So there we go. Ground's fixed, wires are reconnected. I'm going to go through the rest of this thing and give it a very close inspection. Make sure we don't have any other loose connections. If you got one of these Sunns, pay attention, because these problems are probably in your amp too. So take the time, check these things out so you don't have catastrophic failures from loss of bias or power supply fluctuations. During my inspection, I found another major issue. See this capacitor right here? I'm guessing this is probably one of the grid coupling caps to the output tubes. See that connection right there? Watch. Boink! It's just sitting in there. Now this is a common problem with amps that are built this way. What they do is they just take these component leads and put them through the little terminal boards here and solder them. They don't wrap it to get a mechanical connection. I've seen this a lot in Marshall amps too. And for an amp this size, with a road vibration, and you look at the weight of that cap, he's going to pull loose. And this one did. Something else to look for. So as you can see, this amp is one of those that keeps giving you neat little repair scenarios. There's a lot of them. So I'm going to take my magnifying glass and I'm going to inspect every connection in this amp before I dare apply power. Here's the list of casualties. I'm getting ready to install the new 5AR4s, but first I'll pull out the output tubes that are in it, make sure the power supply comes up, make sure we see negative bias before installing the output tubes. After a thorough inspection under the magnifying glass, I believe I've taken care of all the connection issues. So now we're going to power it up. I've got the new rectifier tubes installed. The output tubes are not installed. I've got a variac here, and I have 2 meters hooked up with a load resistor on the power supply. So what I'm going to do is I'm going to bring this guy up to about half voltage, 50 to 60 volts. Let's go take a look at those meters. So here's variac, about 60 volts AC. And monitor the current, see if I see any fluctuations. Looks good. Swing over here. This meter is looking at my negative bias. This meter, that's ramping up slowly, is looking at the high voltage coming off of those GZ34s. And there's a little load resistor to kind of keep things stable. The reason I'm not going full voltage is because there's no load here and I don't want to exceed the value of the filter caps. But so far, no smoke. Good sign. Here in a minute, we'll put in some sacrificial output tubes, make sure it's stable, and then we'll put the new tubes back in. It's time for the initial test with some sacrificial 6550s installed. I don't expect any problems, but if I do have problems, I don't want to take out good tubes. So here's my meter. And he is monitoring the negative bias to one of the output tubes. Got a little dummy load resistor plugged in. And once again, we're going to bring it up on the variac, nice and slow, and watch the current. So here we go. Variac is on. Drawing about a half amp. And she's calming down. Got negative 31 volts over there on the tube. So that's 60 volts. Take her up to about 70. And we're going to let it sit. Make sure there's no smoke. But I'm pretty confident that this thing's going to work just fine. So I always like to sit here and watch them. Watch the current. Because if there's something wrong with the tube, you're going to start seeing the current bounce. Okay? If I see that, I'm going to kill it. But right now, it's looking great. So I'm going to bring it up to full voltage. So now I'm at about 110 volts. There's my negative bias. No smoke. Tubes are on. Now I'm going warp drive. I think we're good. So next, I'm going to hook up a scope, inject a signal, make sure we get audio out of it. Alright, we're powered back up. Now in this case, I've hooked up a scope across the output resistor there. I've got a little dummy load on there. And we got a little Viz audio generator providing some audio to this guy. I'll bring up the volume. Looky there. Boom. Boom. Let's watch the bias. Make sure that is stable. Up, down, up, down. Looks good. Now, I can't really crank on this because I've just got this little 10 watt resistor. Okay, we don't want to burn him up. Should see a little bit of current as I'm doing that. Yep. Good deal. It's time to put in the new tubes. So far, she's looking great. Here's our matched quad of 6550s tungstels from the Tube Depot. These guys burn these things in, and I've had great luck with the tungstels. I'd highly recommend them. Let's get them in the amp. So there's the new tubes. Go over here, crank them on. Once again, I'm at 60 volts. I'll let things warm up, watch the current, watch the negative bias, and we'll test it on the scope with the audio generator. So we've stabilized about negative 53 volts. Now I'm not up to full line voltage yet, but there's my scope. Nice clean sine wave. Looking good. So next step, I'm going to plug her right into the wall. No variac to protect it. Alright, we're plugged in. The power switch is on. Standby is not. You can see our negative voltage sitting around negative 60. That's normal because we don't have plate voltage on. Okay? So everything's looking good. No fire. Let's crank on the standby. See what it does. Boom. There's our negative bias. Everything looks wonderful. How about the scope? Yep. Looking good. Alright, so at this point, I'm going to start my burn-in process. We're going to hook up a real speaker, let this thing bake for a while. But I believe the sun has risen. Now we've entered the burn-in stage. The amp's fired up. Audio generator there. Pair of Celestions. And we can vary the frequency if we want. But I'll let this thing sit here on the bench. Bake it a little bit. I'm going to recheck the bias. Make sure it's good and stable. But it looks like a success. I was kind of concerned there when I heard about the rectifier tubes flashing. But the cause was a shorted output tube, so she drew maximum current. It does still have the original filter cap, and I normally put my fingers on them after they've been on a while. If there's any leakage, they'll actually start warming up. This one's cool as a cucumber. The other thing I wanted to point out is I use these Sovtech GZ34s. They're under 20 bucks, and they're a great rectifier tube. I've never had an issue with them, as well as the tungsol output tubes. You buy those, and you have nothing to be worried about when you repair these vintage amps. So it looks like we have a big success here. And as you can see, I'm very meticulous about what I do. I check and double check, especially when it comes to these big 100 watt amps. Because you make a mistake and you take out your new set of 6550s, that's a big mistake, especially for somebody like me that does this as a hobby. Hope you enjoyed it, and there'll be more to come from D-Lab Electronics. See you.